Hello, my name is Ariana Dyer, and this summer I've been conducting research in the Hybrid Micro-Nano Manufacturing Laboratory at Rutgers, New Brunswick. Here, I worked on 3D printing Pluronic F127 lattices in order to spray them with methylcellulose nanowires and encapsulate them with Agarose gel. Pluronic F127 is a gel that gels between 25 and 35 degrees Celsius and is a liquid at room temperature. A 3D printer was modified to include a syringe. The motor that normally pumps the material from the printer's extruder tip was used to apply pressure to the plunger of the syringe, effectively allowing the printer to 3D print a Pluronic F127 solution. The Pluronic F127 solution was printed directly onto a heated silicone wafer. The wafer was then moved to a hot plate, which was set at 45 degrees Celsius, and sprayed either with a shellac solution, which was dyed with oil blue dye, or with a methylcellulose solution, using electrospray deposition. Electrospray deposition is a coating process which is used for three-dimensional coatings. This process is achieved by spraying a solution from a needle tip through an electric field. Hot agarose gel was then poured onto the sample and allowed to cool and harden for 10 minutes. Agarose gels between 34 and 38 degrees Celsius and could therefore gel around the structure so that an imprint of the printed sample was left in the agarose gel when it was removed. Electrospray deposition was utilized here so that the sprayed material could be deposited into the imprint left in the agarose gel. The agarose gel encapsulated the Pluronic F127 lattices successfully, as it was able to maintain the shape of the structure after it was removed. In addition, the blue-dyed shellac could be seen in the grooves of the imprint in the agarose after it was removed. This means that the shellac solution was successfully transferred from the Pluronic F127 structure on which it was sprayed to the agarose encapsulant. After the printing process was complete, microscopic images were taken to ensure that the sprayed material had been deposited onto the Pluronic F127 lattice. Although the shellac particles were clearly deposited onto the lattice, it is less clear whether the methylcellulose spray was deposited. This could be because of the differences in the sizes of the particles. The methylcellulose nanowires' thicknesses have been shown to be less than 1 micrometer, while the shellac droplets are larger, as can be seen in Figure 3 on the poster. Our results indicated that the Pluronic F127 structure should be printed directly onto the silicone wafer to improve the coatings of the lattice, and that the wafer should be preheated to 35 degrees Celsius to ensure that the Pluronic F127 gel remains firm during the printing process. More investigation into spraying with the methylcellulose solution is recommended, as it is less clear whether it was efficiently deposited. Using longer spray times and imaging the sample before and after spray might make the changes in the sample easier to observe. In addition, while the agarose encapsulant was mechanically peeled off of the Pluronic F127 structure during these experiments, solvent etching would likely be a better technique for removing the methylcellulose or the shellac. In the future, this work could lead to the construction of detailed models of the human vasculature system and to creating artificial human organs using 3D printing techniques. Thank you very much for your time and for your attention.